Hi, I'm Chris Sussersick. I'm a project engineer on this municipal project. It's a project that is designed to pump water from a river into a wet well located underneath the floor, and then pump the water out of the wet well into a reservoir 5 miles away. There are 4 individual 1,000 horsepower motors, and Zesco is the supplier of the pump controller behind me, which controls the operation of the pump motor and the discharge cone valve. With these pump controllers, we have been able to control the operation of the system, providing pressure and flow of these 1,000 horsepower pumps. This has been achieved by an internally developed control scheme that uses 3 main control variables: pump discharge pressure, pump motor power consumption, and the cone valve position. There are also a number of secondary control variables that go into play to compensate for certain hydraulic and mechanical time constraints of the associated discharge cone valve. I'll go into this in more detail. First, we'd like to give you a view from 20,000 feet of the overall installation, the 4 pumps, and the 4 pump valve controllers. The pump controller consists of a number of operating components. The main component is the 4 kV solid-state reduced voltage starter. The starter provides a controlled motor acceleration, reduced current during acceleration, and has fully functional software that provides the motor protection features. It also contains a fully line start rated vacuum bypass contact. This component is located on the right side of the controller, and the voltage is provided through the disconnect. And then there's also 3 low voltage compartments. The 3 low voltage compartments include the soft start control panel, the HMI panel, and then the PLC and relay panel. Mounted on the left side of our soft start panel is our main control panel, which houses our Allen Bradley Complex Logic PLC with Ethernet capability, our digital input and outputs, then our analog input and outputs. And then all of our interfacing goes through interposing relays. We chose the Schneider brand for the ease of wiring, the locking tab, which locks it into its activated position, and then all these tabs, which give nice display and easy to read. And then all field connections go to switchblade terminal blocks, and so we can isolate signals if need to. The center low voltage compartment contains the HMI, our DC power supply, a convenience outlet, a line filter with surge protection, and then the RTD boards, which the RTDs are directly wired in, which eliminates a terminal board, which would provide cold junction points, which may screw up the signal. Then also, we have our stack light. White shows that powers onto the unit, or medium voltage. Green shows the pump's running, and the red shows that we're in a warning or a faulted state with the controller. The last low voltage compartment on the right houses the soft start, programming HMI, and the CPU boards, as well as the switch to throw the 2-speed motor from its low speed to its high speed windings. I'd like to give you a tour of the equipment that we're controlling. We'll start with the motors. They're 1,000 horsepower, 4160 volts, and 900 RPMs. This one has a dual winding, so we can go into a low speed mode. On the far side, houses the terminal connections for the power, as well as surge arresters. And then over here on the right side, we have a smaller terminal box, which I'll show you inside here in a second. Inside the small terminal box, we have our RTD connections, our vibration sensor, as well as a 0-speed sensor. Downstream of the pump is the hydraulic cone valve. This hydraulic cylinder controls the opening and the closing of the valve. There is an hydraulic pump which charges the accumulators, which in turn runs the pump. At the top there is our feedback sensor, which sends an analog feedback over to our controller, and then we compare that to our commanded position. And then there is also end of travel limit switches, which we use. This is the cone valve control panel. It has a position display that will show the percentage of valve open, valve closed, valve open that work off the limit switches, power on activation light. There is a low accumulator pressure, and then there's an emergency stop, as well as an emergency stop local push button here. And then there's a safety stop, which activates when either the accumulator pump has been running for too long, or the power disconnect has been thrown. And then from the soft start controller interface, we can send an emergency close signal and shut the cone valve in a fast sequence. This is the pump curve for this project. This is the design point right here at 27,000 gallons per minute. And then with our control scheme, you can also go into low flow mode, which goes back to about half of that rate at about 14,000 gallons per minute. About right there on the curve. And then there's also the ability to go into manual mode, and you can select anywhere along this curve through our control sequencing in manual. Two other things to point out on the pump curve are the pump efficiency and the pump brake horsepower. At our normal flow rate, you can see that we maximize our efficiency as well as our pump brake horsepower. But as you go out onto the pump curve, your efficiency falls off as well as your braking horsepower. Between the pump and the valve controller is our discharge switch, discharge pressure switch. We have to have a minimum pressure before we'll bring our valve opening sequence on. This is the pressure transducer on the downstream side of the pump system. It sends a 4 to 20 analog signal back to our controller. And then there's also a purge valve in the sensing line. And so with this one, you open up the flow into the transducer. You remove this plug, and then you open up this switch in front to have the air purge. And you close it, return the plug in, but you leave the sensing line open. Here are our level monitors. They're the Siemens Hydro Ranger 200s. And what we get from these is 2 units, 2 wet wells. Each one sends to 2 of our controllers. We get a 4 to 20 signal from these. And then there's also a failure, a digital contact that we take back, which signals either loss of power to the unit itself or a loss of echo from the transducer. Then also in these wet wells, there's low level floats. Our pump controllers enable these individual capacitor banks. The controllers activate them about 4 minutes after the start of each pump. There's also an interlock that prevents closing of the cap bank while one of the individual units is starting. And then that interlock is disabled at full voltage. This is the Allen Bradley Panel View 1000 that we chose as our HMI. This is the main screen, which shows your current pump operation, your pump selected flow rate, and then you have a visual cue of the pump being red for off, green for being run. You show your downstream pressure from the transducer, our motor current. We have a display for our wet well level, for our commanded position for the cone valve, and then the actual feedback position of the cone valve. And then there is a help screen that tells you all the visual cues of what you're looking at. And then here at the bottom is buttons to navigate through the other screens. The next screen is our PLC I/O. Then you can choose between digital I/O and analog. With the digital, it shows the status of all our input relays, of all the both modules, as well as our outputs. Through the analog, you can see the level of our 4 to 20 signals that we take in, as well as we are outputting to the SCADA system and the cone valve position. Our first navigation key is our alarm and fault. When you push that, it comes up. It shows you an alarm time, the acknowledgement time, and then it displays what the actual fault is. So I'm going to create one real quick. And today at 3, we had an emergency shutdown. I will acknowledge it. And that time comes up to display that. And you can cycle through all the alarms with the up-down arrows. And then after you acknowledge the alarm, you reset it, and you can clear the history. The next navigation key is the pump start permissives. And this screen shows everything that you need to run the pump, whether you're in auto or in hand. You need a check mark, needs to be by each line to let the pump start. Then also, there are 2 permissives for the valve opening sequence. You have to have the pressure switch, has to be activated, and then the pump also has to be at speed. The last navigation key is the settings. And everything in here affects the operation of the pump and our flow sequencing. This is done at the engineering level and should be coordinated with the on-site engineer. I'm going to give an example of changing between the low and normal flow modes. And so you go into settings 2, click on the normal flow, click the down arrow to go into low, and then enter in. And now we're in low flow mode. The timer and delays navigation key takes you into times and delays that you can program in with the opening and closing of the cone valve sequence. And then there's also a section where you can put a time delay in your alarm and fault recognition. The last piece of equipment that we interface with is the SCADA network, which controls the soft starts while we're in the auto mode. Then we receive a start stop, and then we pass back and forth digital and analog I/O to the SCADA interface.